Hey guys, we are moving into sections 4.4 and 4.5, which deal all about scatter plots and linear regression lines, something that I think most of you are pretty familiar with and pretty comfortable with. So let's take a look at this. So first thing, what is a scatter plot? So a scatter plot is a graph that shows a relationship between two data sets. The two data sets are graphed as ordered pairs in a coordinate plane. It's important when you're creating a scatter plot that you understand that a scatter plot can only be used for what we call quantitative data, meaning data that gives you numerical or number answers. So for example, I can't create a scatter plot comparing people's hair color to eye color, because both of those are what we refer to as categorical data, where people would answer with words and things like that. But I could create a scatter plot with anything that's numerical, such as looking at the number of photos you have on your phone compared to your Instagram followers or something like that. So as long as it's something in which people can answer with something that is numerical, we can create a scatter plot based off of that information. So here, a little exploration just to kind of show you what a scatter plot would look like. Here we're looking at the scatter plot between the husband's age and the wife's age. And obviously you would think that there would be some type of correlation or relationship between that data. We could draw a line in that approximates that data, and that line would be the line that's closest to as many of the points as possible. Within a data set, we have what's referred to as correlation. Correlation shows the relationship between the data sets, okay? And we can use a scatter plot to describe that correlation. We have what's referred to as positive correlation, negative correlation, and no correlation. So this would be negative, and this would be no correlation, okay? If we look at our graph on our left, we can see that the data values are going up as we look from left to right. As x increases, y is increasing. Hence, we have a positive correlation. If we look at our second scatter plot, we can see that our dots are going down from left to right. As x is increasing, y is decreasing. Therefore, we have a negative correlation. And in our third scatter plot, our dots are all over the place. There's no pattern there. Therefore, we have no correlation. Now, it's pretty easy to make a scatter plot, right? We just have to plot our points as if they were coordinate pairs, plotting the x and the y values. Nowadays, there's plenty of technology that you can use to create a scatter plot. So we're going to use one of those that you use all the time, which is Desmos. So let's go ahead and let's use Desmos. We're just going to go to desmos.com into our graphing calculator. And then in order to use Desmos to create a scatter plot, you're going to hit the little plus sign, and you're going to create a table. If we're looking at our data values here, we're going to plot our x values, 82, 78, 68. So I'm just going to plug these in. Then we've got 87, 75, 71. And 92 and 84. And then our y values, 4.5, 4.0, and 1.7. Five 3.8, and 2.9. And then 4.7 and 5.3. Now on Desmos, a couple things that you can do. Obviously, we can't see the scatter plot right there. So we could zoom out. And there you can see the scatter plot and the values right in there. Now notice that's still not a great look at what that scatter plot is looking like. So what we can do is we can change our window, so where our scatter plot is zoomed into, by clicking the little wrench that's up here. And we could change the scatter plot values. Like for example, I see that all my x's are from values of 68 to somewhere in the 90s. So maybe I want to change my x's from 65 to maybe 92, something like that. And I know all of my y values are somewhere from 1.7 to 5.5. So maybe I'll just do like 0 to 5 as the y-axis. And now I can kind of get a better look at what this scatter plot is looking at. I could still even adjust this even a little bit more. Maybe I want to make this something like 5. Maybe we'll go to 10. Okay. I can see my scatter plot here, and you can see that there is a slight correlation here. If we were looking at our dots, they appear to be going up from left to right. Hence, there would be a positive relationship here. It's not a very strong relationship, but the points definitely are going up from left to right here, and we would describe that relationship as positive. So just to recap, if we hit the little plus sign, we'll get a table, and then we can go ahead and we can see that relationship that exists within our line. So when we're doing this, okay, and we want to use a line of fit to model our data, okay, we want to draw a line that's as close to the points as possible. Now, one such way that we can do this is we can just pick 2 points as a part of our data set, and we can create the line from those 2 points. But notice that there's not an exact linear relationship here. So instead, what we use is we use what's called a line of best fit. And a line of best fit is a line that best fits the data, okay? So when we're talking about that line of best fit, we're talking about a line that it most closely models the data. So when we're doing that, and technology will most frequently do that for you, okay? The way that it does it is that it minimizes what's called the residuals. And a residual is the difference of the y value of the data point and the y value found using the line of fit. A residual can be positive, meaning if the actual data point is above the line. It can be negative, or it could be exactly equal to 0 if the data value is exactly on the line. So when you're asked to calculate a residual, you want to think of it as your observed value, what you actually got, minus the predicted value that your line of best fit is saying that you should get. You can make a scatter plot of the residuals as well, and that's used to determine how well that line of best fit fits the data, but that's something for a more advanced statistics class. So graphing calculators use a method called linear regression to find the precise line of fit that's called the line of best fit. That is the line that minimizes the distance your values are from each other. Okay, that is the line that best fits the data. A calculator or Desmos will most often give a value called R as well, which is the correlation coefficient. That value of R can be somewhere in between -1 and 1, and that value of R tells you the strength of the correlation or the relationship. An R value of -1 would represent a strong negative correlation, meaning that your data values are very close to a straight line going down from left to right. An R value of 0 would represent no correlation, meaning your data points are all scattered about. And an R value of +1 would represent a strong positive correlation, showing that your points are going up almost in a perfect straight line. We're going to do an activity in class where you have to guess the correlation or guess the R value, and we'll make it into a little bit of a competition. So let's find a line of fit. Okay, going through the process and using Desmos to help us find that line of best fit. So back in the old days, we had DVDs, which you guys don't even use anymore. But anyway, this table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release. So the week is X and the sales in millions is Y. And they're also asking us to interpret the slope and the y-intercept of that line of fit. So what are we going to do? We're going to go to Desmos and we're going to enter our data in. So I'm going to clear out this table and I'm going to go and I'm going to add a new table, plugging in my values. So my X values are just 1, 2, 3, 4, 5, 6, 7, and 8. And then my Y values here are 19, 15, 13, 11, 10, 8, 7, and 5. So 19, 15, 13, 11, 10, 8, 7, and 5. I'm going to zoom out so I can take a look at this data, and here it is. I can see that there's a very strong negative correlation here with my data values. We can see that they're going down from left to right, okay? This would represent an R value that's very close to -1. In fact, we're going to find out what that R value is. So now I want to find a line that best fits this set of data. So in order to do that, we have the steps right here. So we've entered our values in, and now in Desmos, we have to type the following. This Y1, then the little squiggly that looks like the Spanish accent tilde, mx1 plus b. So we're going to go back to Desmos, and we're going to do y sub 1. So we have to go down there, their little tilde, mx1 plus b. You're going to see a couple things in here. You're going to see r squared, which is not something that we're overly concerned about right now. You're going to see your m, which is your slope. So your slope is -1.833, and you're going to see your y-intercept, which is 19.25. Notice the r value that's right here is -0.9833. Very, 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 very close to our value of a -1, showing which would be a perfectly straight negative line. Now notice here, here's your line that best fits the data. You have some of your data points that are below the line, some of them that are above the line. All of these data values that are above the line would have a positive residual. All of these data values that are below the line would have a negative residual. This point is almost exactly on the line and would have a value that is very close to 0 for the residual. But we're asked to write that line of best fit. So that line of best fit is going to be y equals, and now plug in your value for the slope, which is -1.833. plus 19.25. So our equation, once again, y equals -1.833 plus 19.25. It's important when you're doing these that it's telling you to interpret the slope and the y-intercept, okay? We're going to go through exactly how to do that as a part of class. But keep in mind and try to come up with what you think that y-intercept means and what you think that slope means in the context of this problem. This slide right in here just goes through how you would go about doing these steps on a graphing calculator. Now, because we don't have graphing calculators at home, I think it's easier to use Desmos to find that line of best fit. Final thing as a part of today's lesson deals with two vocabulary terms referred to as interpolation and extrapolation. When you have that line of best fit, it's important that you only use that line of best fit to predict for values that are part of your data set. So for example, we would only want to use this line of best fit to predict for values that are in this range right in here, x values from 0 to about 10. I don't want to use this line of best fit to predict for values outside of that range, because then I end up getting answers that are unreliable, okay, that are not accurate. That's what's referred to as extrapolation. So if I were to use my line to predict for, say, an x value of 12, notice how I get a negative answer, which doesn't make sense in terms of the sales, because your line of best fit can only be used to predict for values that your x values exist at. So only in this range, hence interpolation. Only using it to predict for values over here, not using it to predict for values over here or values down here where we don't have any actual data values that exist. We're going to do a lot of practice with Scatterplots and lines of best fit as well as a project, but hopefully you have the basics and foundation down. See you guys.